Hello friends, I'm Jagdish, Perk Associate. Today's topic is Engineering Thermodynamics. So in Engineering Thermodynamics, I will be explaining a numerical problem from the chapter First Law of Thermodynamics. So before going to this video, please press the subscribe button of our channel, the Mechanical Engineers team, and also click the bell icon so that you will get the notifications for new videos. So let's begin. First, I will read the question. In a cyclic process, heat transfers are plus 14.7 kilojoule, minus 25.2 kilojoule, minus 3.56 kilojoule, and plus 31.5 kilojoule. What is the net work for this cyclic process? So this is the question. Now we will analyze the question. Here it is a cyclic process. The best example for cyclic process is sun. Because every day the sun rises in east and the sun sets in west. So this happens every day. So therefore the sun undergoes cyclic process. Okay, similarly in thermodynamics, the sequence of process will not change. So such kind of process is known as cyclic process. For example, the process starts from process 1, continues to process 2 and ends in process 3, and again comes back to process 1, continues to process 2 and ends in process 3, and again comes back to process 1. So this cycle continues. So this kind of process is known as cyclic process. Second, in this question, 14.7 kilojoule minus 25.2 kilojoule minus 3.56 kilojoule and plus 31.5 kilojoule are four different heat values from four different processes. So in this question, we have to find the value of net work. Now we will look into the formula used for finding the value of net work. And the formula is cyclic integral of dou q is equal to cyclic integral of dou w, and this is the basic formula for cyclic process. Now we will move to the solving technique. First we will find the value of cyclic integral of dou q. For finding the value of cyclic integral of dou q, we have to just add the four different heat values from four different processes. Okay, it's just simple. We have to just add the four heat values. Okay, so cyclic integral of dou q is equal to 14.7 kilojoule plus of minus 25.2 kilojoule plus of minus 3.56 kilojoule plus 31.5 kilojoule. So here plus of minus 25.2 kilojoule is minus 25.2 kilojoule and plus of minus 3.56 kilojoule is minus 3.56 kilojoule. Okay, so the next step will be cyclic integral of dou q is equal to 14.7 kilojoule minus 25.2 kilojoule minus 3.56 kilojoule plus 31.5 kilojoule. Okay. So in this RHS, 14.7 kilojoule minus 25.2 kilojoule minus 3.56 kilojoule plus 31.5 kilojoule is 17.44 kilojoule. So the next step will be cyclic integral of dou q is equal to 17.44 kilojoule. So we have found the value of cyclic integral of dou q is 17.44 kilojoule. We know that the basic formula is cyclic integral of dou q is equal to cyclic integral of dou w. So we will just substitute this value in the basic formula. So we get cyclic integral of dou w is equal to 17.44 kilojoule. Okay, which means the net work for this cyclic process is 17.44 kilojoule. Now we look into the solution. The solution is the net work for this cyclic process is cyclic integral of dou w is equal to 17.44 kilojoule. So friends, this brings an end to the explanation part of this video. I hope you all would have understood. If any doubts are there, please do comment in comment box and remember to like, share and comment on our videos. Thank you friends.